Hi guys, today we're going to talk about quadratic systems and how to solve quadratic systems by graphing them on a coordinate plane and then seeing where those two graphs intersect. So the essential question today is, how do we solve quadratic systems by graphing? And when we talk about quadratic systems, we're talking about a system of equations, so a set of two or more equations, one of which at least is quadratic. The other, if there's two equations, the other one could be quadratic or it could be linear. And so today we're going to talk about how to solve by graphing and what those solutions look like. Remember that the solution to a system is the point, the location, where the graph of those two equations intersect. And so if we're talking about throwing in a quadratic equation into the system, that means that one of the graphs is going to be a parabola. So it's possible that the equations will intersect in two locations, meaning that you will have two real solutions. It's also possible that if you have a quadratic equation and a linear equation, that your two graphs might intersect in one location. So the equations will look like they intersect in one place, and you'll have one real solution. And then the third and final possibility, if you're graphing a system that has a quadratic and a linear function, is that whenever you graph them, there's not any location, any possible way that these two graphs could touch, and so the equations will not intersect and you'll have no real solutions. So that is a possibility as well. The process to solve systems of equations that may have quadratics by graphing is that first you need to solve for y in your equations, because the purpose of solving by graphing is to figure out where the solutions are, and you can't do that unless you have your equations look like y equals. The next thing you want to do once you have y equals and y equals is you want to graph your equations, both of them. If your equation is linear, then you want to plot the y-intercept and then use the slope to count rise over run. Your linear equations will look like slope-intercept form, y equals mx plus b, or they may look like point-slope form, y minus y1 equals m times x minus x1. Now granted, if you solve for y in your equation, then you're going to end up getting this, but it's possible that you might have this to start out with. If you can identify point-slope form, then you might be able to just graph your equation as is. So if your equation is linear, plot your points, your y-intercept and your points from your slope. If your equation is quadratic, then find the vertex using negative b over 2a, and then use the quadratic pattern discussed in the last set of notes to plot more points. So over 1 up 1, over 1 up 3, over 1 up 5, over 1 up 7. Remembering that if your a value in your quadratic function is anything other than 1, then you're going to have to change that quadratic pattern up a little bit. You want to find any points of intersection. Those ordered pairs create the solutions for your system, and you want to write the solution as those ordered pairs. So your answers are going to be like x comma y and x comma y. They're not going to be x equals something and x equals something. We want the actual full points. Okay, so let's look at some examples. In our first example, we have two equations. I notice this one has a squared and this one does not, so that means that this top one without the squared is linear. And I would really like to solve for y so that I can get slope-intercept form and I can graph my line a little bit more easily. So I'm going to move this minus 2x to the other side. If it's minus 2x on the left, it's going to be positive 2x on the right. This looks like y equals mx plus b now, so my y-intercept is negative 2. My slope is 2 over 1. So I'm going to rise 2, run over 1, rise 2, run over 1, rise 2, run over 1 until I can't go anymore. I'll also extend my line backwards, down to back 1, down to back 1, and so on. I'm going to use a straight edge. And I'm going to create my line. And there's equation 1 graphed. Now, the second equation, because it had a squared, it's quadratic. And in order to graph the parabola, well, first I need to figure out where the vertex is. And the vertex's x value comes from using negative b over 2a. So negative b is negative 4, over 2 times a, which is 1. Well, we know from the past that negative 4 is really positive 4 over 2, so that's just 2. And in order to find the y value, I'm going to take 2 and I'm going to put it in place of all the x's in my quadratic equation. So y equals 2 squared minus 4 times 2 minus 2. 2 squared is 4. Minus 4 times 2, that's minus 8, and then minus another 2. 4 minus 8 is negative 4, minus 2 more is negative 6. So my vertex is at 2, negative 6. So I'm going to go ahead and plot my vertex at 2, negative 6. Whoops. 1, 2, 3, 4, 5, 6. I look at the a value here. It's positive 1. That means that my parabola opens up, and I can use just my regular quadratic pattern. Over 1 up 1, over 1 up 3, over 1 up 5. So over 1 up 1, over 1 up 1, 2, 3, over 1 up 1, 2, 3, 4, 5. I could probably fit in another one, over 1 up 1, 2, 3, 4, 5, 6, 7. Look at that. Same thing on the other side. Over 1 up 1, over 1 up 1, 2, 3, over 1 up 1, 2, 3, 4, 5, and over 1 up 7 all the way at the top. So my parabola has a vertex here at 2, negative 6, and then it goes up like this. So when you find your solutions, you're looking for the places where your graph intersects. So we've got 1, 2 points of intersection. Those 2 points of intersection are at negative 2, 0, and at this point, which is 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 6, 10. Those are my 2 solutions because those are the 2 places where my graphs intersect. Lovely. Okay. Let's move on to number 2. Again, we have a system of equations that has 2 equations. This first one has a squared and the second one doesn't. So that means that this is quadratic. This is linear. I'm going to start out with my linear equation because I feel like we're a little bit more comfortable with linear equations. So my y-intercept is 5 and my slope is 3 over 1. So I'm going to graph 1, 2, 3, 4, 5, and then my slope is up 1, 2, 3 over 1. Backwards. So down 1, 2, 3, back 1. 1, 2, 3, back 1. I'm going to keep going until I can't fit any more points on the graph. So I'm going to use my straight edge. And there's my linear equation. For this one, I can certainly use negative b over 2a. However, this looks pretty basic. Like if I cover up this plus 1, y equals x squared is the parent function. And the last set of notes we talked about was transformations. And if you have plus 1 on the outside, what exactly does that do to your parabola? It shifts 1 in the positive vertical direction, so we're shifting up 1. So I'm going to take my vertex of 0, 0 for the parent function, and I'm just going to shift it up 1. And I'm going to use my quadratic pattern to graph the rest of my points. So over 1 up 1, over 1 up 1, 2, 3, over 1 up 1, 2, 3, 4, 5. Same on the other side. Over 1 up 1, look at that. Over 1 up 1, 2, 3. Over 1 up 1, 2, 3, 4, 5. Now I noticed something. I noticed that whenever I graph my parabola, whoops, and I go up, this is going to continue, and this is going to continue. And so I know that one of my solutions is here, -1, 2. But I know that there's going to be another one. And so I'd like to kind of extend my graph to make sure that I have them in the right spot. So my next part of the quadratic pattern would be to go over 1 and up 7. So 1, 2, 3, 4, 5, 6, 7. And I also want to make sure that I'm using this slope to go up some more. So up 1, 2, 3 over 1. Up 1, 2, 3 over 1. Up 1, 2, 3 over 1. So I do have this point right here where they intersect as well. And that'll be 1, 2, 3, 4, comma, this is 10, 11, 12, 13, 14, 15, 16, 17. So it is possible that you might have to extend off of the graph. Okay. So let's look at examples 3 and 4. These are the last ones that we have. Notice that in both of these equations, in problem 3, we have squareds. So they're both quadratics, and they're both going to create parabolas. So let's talk about this top one first. For this top equation, x squared minus 4x plus 4, I need to find the vertex. So negative b would be negative 4. 2 times a would be 2 times 1. Negative 4 is 4. Divided by 2, that's 2. And I need to find the y value for this problem. So I'm going to go ahead and substitute 2 in place of x. I have y equals 2 squared minus 4 times 2 plus 4. So 4 minus 8 plus 4. 4 minus 8 is negative 4. Plus 4 is 0. So my vertex is at 2, 0. Now I'm going to use my quadratic pattern to find the rest of the points. So over 1 up 1, over 1 up 1, 2, 3, over 1 up 1, 2, 3, 4, 5. Other side, over 1 up 1, over 1 up 3, over 1 up 5. So there's your first parabola. Your second parabola, you need to do the same thing. So what I'd like for you to do now that I've shown you several examples, I'd like for you to pause your video and try to do the same thing with the second equation that we did with the first. So I want you to try and find the vertex. Once you get it, I want you to plot it and use your quadratic pattern to find the rest of the points on your parabola. So pause your video and try the next equation. So in this problem, negative b over 2a becomes negative 2 over 2 times 1. That simplifies to negative 1. When I substitute negative 1 for x in this second equation, I end up getting negative 3. So the vertex is at negative 1, negative 3, which is right here. I use my quadratic pattern to go over 1 up 1, over 1 up 3, over 1 up 5, and the same on the other side. I notice that there is a point of intersection. How many points of intersection? Just one. So I only have one solution, and that ordered pair is 1, 1. So that is my solution. All right. So last problem that we have in our notes today is number 4. And I notice on number 4 that we have what kind of functions? We have 2 quadratic functions again. I also notice that here a is 1, but here a is -1. So we're going to have one parabola opening up, and we're going to have one parabola opening down. So just things that my eyes see whenever I look at these equations. So what I'd like for you to do is pause your video just like you did a second ago, and I'd like for you to try to calculate the vertex for each of these quadratic equations, plot each of them, and then use your quadratic pattern to try and come up with the rest of the points on the graph. So take a moment, pause your video, and try to find all of the pieces. So in the first equation, x equals -b/2a gives an x value of 3. When you substitute 3 in place of x in the first equation, you get 3. So my vertex is 3, 3. So I plotted it and I used my quadratic pattern. Since a is +1, it opens up and it's just over 1 up 1 over 1 up 3. I don't have space to do over 1 up 5. For the second equation, my x value for the vertex is 1, and when I substitute 1 in place of x in the equation, I get 2. So 1, 2 is my vertex. I do notice that this parabola opens down. It's been reflected over the x-axis before it's been shifted up 2. So instead of going over 1 up 1, I have to go over 1 down 1, over 1 down 3, over 1 down 5. And what do you notice about these two parabolas? There's no point of intersection. That means that this set has no solution.